Hello, welcome everyone to this meeting of the Interplanetary Network Special Interest Group. We're going to be talking about delay-tolerant network projects in work and going on. I'm Scott Pace, the moderator from the Space Policy Institute at George Washington University, and our prime presenter leading us through this will be Oscar Garcia, who's the Pilot Projects Working Group lead for the IPNSIG and board member of IPNSIG and the PWG team. The obvious question that people will ask is, when can we get the slides? So I would suggest joining the IPN Academy is one of the best ways to keep up with all the material that we're doing. I also like to acknowledge some special guests. We have Vince Cerf on the bridge from NASA, and I know we have a number of NASA colleagues who are also joining us. Next, this session is going to go fairly quickly. We really only have about an hour for it, a number of presentations. So you might think of these as kind of like lightning talks, enough of the abstract to get a sense of what's going on. Rather than going through everyone's bio, I'm really just going to introduce folks, and you can, I think, read the bio. We really have people with some amazing backgrounds. I would do a disservice to try to be brief about them. I have to let the work speak for itself. With that, I'd like to turn over to Oscar Garcia to get us going, and he's going to be talking about DTN works and the Pilot Projects Working Group, a general overview of what he's been doing. I should mention, violating my comment about bios, he presented the first medical record system for space exploration in 2020, received award from the World Summit on Information Society and Digital Health, nominated for the Arthur C. Clarke Award, British Interplanetary Society. So done all kinds of great things. Oscar, you're first up.
Thank you very much, Scott. I would like to say that I show my appreciation to Dr. Scott Pace for being our moderator in our presentation. Because he is not only an expert in international relations, also on space and space research, and also he has served in the National Space Council and of the United States. Well, we can start. This is the presentation of the IPNSIG Academy. We are not only I'm going to talk as keynote speakers, I also invited all my team, all our group that has several developments to show them. So next slide. We, at this point, we started talking about the Pilot Project Working Group with some very important persons in this area that were being observed. You know him as the father, one of the fathers of the internet, Scott Barley, that's in the board of the IPNSIG, about the development of the technology of the interplanetary network, and that happened 2 years ago. And we are interested in testing all the technology that is going to be used in space for communications and to develop what we call an interplanetary internet. With that goal, what happened was that we said that we needed to develop a network, and this group that with the support of the chairman of the IPNSIG, Kaneko Yosuke, who is also part of the JAXA, the space agency of Japan. I started that to the goal that bringing members in several continents to develop technologies to test and refine the delay and disruption tolerant networking protocols that allow the communication to generate an interplanetary internet to be used on Earth and on space, and communicating as space exploration is starting very, very in a very important way nowadays. So we started with this model, and we started the pilot projects working group. Important things to mention is all the demonstrated projects are funded by the membership of this group that we say the PWG. This is slide, please. The first project, testing experiment that we developed was to connect using the DTN technology of communication between the cloud servers. You know that most of the internet nowadays running clouds. So we made a connection between different cloud servers, but not only on the internet, but using the DTN protocols. That was the first time that it happened, as far as we know. And it happened in Friday, November 27 in 2020. And we did that with Winfield Surf and with Dr. Larissa Suzuki, that he was in London, and myself. And that was, we call that in a historical moment in which we could do that. As a brief timeline, well, we say that in November in 2020, we did this connection with clouds. In January 2021, we launched the PWG. In May 2021, with several members that are here in our webinar, we made an experiment with the satellite, the CubeSat of the European Space Agency, called the OPSAT, with the help of the a German company that is also very involved in DTN. This is called DTN, and we connected two different models, or what we call implementations, in DTN. In January 2020, in July 2021, we presented our testing plan to the community in the IETF, the Internet Engineering Task Force, and we presented the software that we were developing. We were honored in January this year, 2022, to be invited to present our works to NASA working group, DTN working group, and also a video is shown, is public now, where we present our works as we are doing today. And in May this year, we presented the DTN network that we launched, this DTN network, with many of the members that are now here. Our group has meetings permanently with several of the leaders in this field. Winfield Surf, Scott Barley, that developed the IOM protocol, the IOM implementation with the Jet Propulsion Laboratory NASA, Rick Taylor, that is co-chair in the DTN group in the IETF, were leaders in business, in space business, with NASA DTN working group, with another of the groups in the IPNSIG that is working on architecture and governance, where also Scott Pace is part of this group with the IDF. We have presented in EuroDIC, the digital dialogue in Europe, in Utica universities. Well, we are also making like a public awareness of this technology. I am going to talk a bit about the DTN testing plan. Next slide. When we presented that, we shown up some of the goals that you have there. They are very technical in some cases. Sending bundle system, the model in which this communicates. I don't want to go so technical because and the audience are very expert and perhaps other not, but we sent out we tried to show this with the bold with the idea of test interplanetary internet at home before you go to space. Well, this is a diagram of things that we are accomplishing slowly, but not so slowly, that is connecting personal computers with the DTN protocol, with the DTN technologies, some corporate networks, universities, data centers or cloud servers, and also we are planning in the next future to connect with satellite networks so we can start testing all these. Finally, about the infrastructure, I would say that Dr. Alberto Montilla, that's also a member, would be our next speaker, showing the technology that we implemented in the network. Thank you.
Thanks, Oscar, and good day all. This is Alberto Montilla speaking. I'm a board member of the IPNSIG, an avid collaborator in the pilot projects working group, and co-founder at the Spartan Corporation. So my goal is to talk a little bit more about the network and the infrastructure in it. So the infrastructure is basically composed by, as you may imagine, the DTN nodes, and the DTN nodes are deployed in multiple ways, all the way from, directly into hardware servers, into embedded devices, and into virtual/cloud servers, including deployment on AWS, Google Cloud, Microsoft Azure, as well as embedded devices such as Raspberry Pi and similars, and then, physical servers. The network right now is composed by, tens of nodes. Some of them are permanent in the network so that we can test things and we can allow others to connect to the network. And some others are more ephemeral based on the experiments we run at times. As an example, the ESA and the experiment with the European Space Agency and DTN with the OPSAT satellite that Oscar mentioned, and Alberto Jr. is going to talk about it. Very important is, our goal, as Oscar said, is test the core foundational protocols that makes the software stack, such as the bundle protocol, also to test and develop applications on top of it. So to understand how things such as conversations, file transfer, as well as other real-time traffic runs over the network. That way, we not only help the organizations and ourselves in evolving the protocols, but also we share our common understanding and our knowledge of the data tolerant networks. This is very important for us because keep in mind that one of the purposes of the IPNSIG as well as ISO, the Internet Society, is to ensure that Internet is for all, and that doesn't exclude the interplanetary and the upcoming interplanetary Internet. So in addition to the network, in addition to applications, we have a series of, we're developing a series of tools that helps our members into contributing to the testing and also contributing to joining the network, like the DTN test suite, as well as the DTN manager and other labs, such as what Jorge is going to present. There's something I want to mention, and it's very important, is that this is an open collaboration. This is open to any corporation, any organization in the academy, and any individual students and anyone who has a passion for contributing and learning about the interplanetary network. So if as you want to decide you want to join and join the network, just join IPNSIG, the pilot project working group, and from there you can join. And quickly, this is a snapshot of where some of our permanent nodes and some of the ephemeral nodes are located. As you can see, it's pretty much across the globe right now. We don't have anybody in Australia yet. So if you happen to be in Australia, please, reach out and join. And we run continuous experiments across the different nodes to test applications and to test the node itself.
Okay. And then our next talk is on DTN manager and interoperability. And Mr. Alberto Montilla.
Perfect. Hi, everyone. Yeah, my name is Alberto Montilla Jr. I'm a member of the IPNSIG and the Pilot Working Group, and I co-founder at Spata Corporation. And today I wanted to give a quick look into what we have been developing at Spata Corporation and how these projects have been influenced by the IPNSIG, resulting in our collaboration with the group. Our most important project is the DTN network platform, which is made up of our network manager and managed DTN instances. The network manager originated from a need within the IPNSIG to develop a node registry in order to share network information between members and generate contact plans, which configure the network and determine its topology. Currently, we support a series of network configurations, including a mesh network and the addition of exit nodes or gateway nodes. Our current development focuses in the management and security fronts, where we aim to provide network and node management securely, all via DTN through the bundled protocol. Our managed instances work as cloud or hardware nodes that are built to connect to our DTN platform in order to automate the build and configuration of the network, providing a variety of services both from the application and networking level. So DTN, or the bundled protocol to be exact, exists in a variety of implementations, and the goal of both Spatium and the IPNSIG has been to test the interoperability between these different implementations. And for this reason, last year in June, we partnered with a European space agency and a company from Germany called D3TN that developed their own bundled protocol implementation called Micro D3TN. In this experiment, we communicated with a NASA small sat called the OPSAT to send data to space and receive it through a network that included both Micro D3TN and ION, ION being the bundled protocol implementation developed at NASA by JPL. Here we successfully tested a ring road configuration to leverage capabilities of DTN and provide a useful use case by running an image recognition service through the network. Lastly, our interoperability efforts recently extended from the networking level to the application level, and last month we were able to test applications developed for the ION and Micro D3TN implementations to provide simple messaging and node connection monitoring. So Spatium Corporation is a startup where we envision the future of DTN communications. Currently, we're focusing on our DTN platform formed by the DTN manager and our DTN managed instances. Now, if you're interested in getting in touch, please feel free to reach out to us directly through our contact info at spatium.com. Thank you.
Sorry. Excellent. Thank you very much, Alberto. And our next speaker is going to be talking about DTN network support and by Facundo Novik. Facundo?
Hello to everyone. My name is Facundo Novik, manager of the support area for new users of ION and introduction to DTN. My job in this project is to ensure that people interested in DTN can set up their servers and connect to the rest of the network and make a follow-up to everyone and check if each server works fine. For this purpose, we use the DTN test suite that was developed by the past year. That include a registration form for new users in our blog, and we have a management system of the activity and help for the new users. Well, in this map, we can see the new users in several countries and continents as the network grows. With the DTN test suite web, we also make a follow-up. This is an application developed by Oscar Garcia that allows us to check with vPing to the network servers and see if someone can connect. If that happens, we send an email to advise the user and try to fix the problem or fill the support form if needed. We verify the problem and eventually make a consultation with the rest of the group to help in the solution. Well, this is all my show in this project. Thank you for your attention.
Okay, very nice. And okay, next I want to talk about DTN servers and AdKit developments. John Cook, Michael Moore, you're up.
Thank you, Scott. Greetings, everyone. My name is John Cook, and I'm the CTO at Adirondack IT Solutions. And I'm here today with our chief engineer, Mike Moore. Unfortunately, our chief scientist. Many of you probably know Dr. Ronnie Bull couldn't be with us today. So we're here to update you as to our research and development activities related to DTN. I just wanted to start out by briefly describing where we've been in terms of our past R&D activities. Some of the activities that the Adirondack team has made towards the DTN and development include adding output to BPing and BP Echo to assist in gathering network statistics for DTN testing. A lot of our activities include building out test environments for large-scale multi-node testing. We've been developing an eMain and Manhattan for DTN testing. For individual nodes, we've been doing things on Raspberry Pi and including I/O and device sensor input-output communications type things. In addition to source code development I mentioned, much of our work includes scripts to automate testing and implementation, like node auto configuration scripts. Recently, we've been focusing more on contributions of the ION implementation itself. And I want to turn it over to Mike to let you know what kind of activities we're doing with that.
Hello, everybody. Our activity is pretty much research right now. We were fortunate enough to pick up some NASA work that's starting in about 10 days. And as this slide tries to illustrate, we're working on the idea of a roadmap, starting with the diagram on the right at the bottom is where we would be today. Maybe in 10 years would be down the road. And the difference between now and 10 years from now is there's going to be a lot more things in space, and there's going to be a big difference in radio technology. We're focusing on that software radio technology to help us define ways of improving bundle protocol routing. And we're going to be doing that using ION as our basis. Scott Burlog is helping us with that. And we have kind of outlined several steps here. Our very first try is going to be reactive routing, where we will be trying to, first of all, identify what interactions between what we can expect from an advanced software modem in our stack, if you would, will be coming up from status to help us understand what's going on with the network and what the opportunities are for optimizing routing on the fly. So this is an effort to try to automate what's going on in space, to try to start replacing the very, manually intensive routing of contact graph routing, and start taking steps to make it more autonomous. I'll leave you with a little idea of where we are. We are in New York State, USA, and that's how there's happens. Sorry. We're in New York State, and we're indicated right in the middle of the state. So right now it's summertime, and in 6 months it'll be about 30 below. But right now it's nice and warm. So thank you.
Who says we can't colonize hostile alien worlds when you look at
this? Right here. Yeah.
Great. Thank you. Our next presenter, we're going to have Marianne Winfield and Ernesto Yattah, Unified Medical Records for Space Exploration.
Hello, everybody. Pleasure to be here with all of you. I'm here just to give you some brief information on the Unified Medical Record System, which was created in 2003, servicing more than 60,000 patients and integrating over 1 million clinical tests in the medical record system. As noted a little earlier, Unified Medical Records received the World Summit of Information Society Award in 2005. And also, more recently in 2021, was nominated for the Arthur C. Clarke Award for Interplanetary in the Interplanetary Society. Our motto is your medical records wherever you are, now in space too. So for more information, please visit the website. Thank you.
Thank you, Marianne. My name is Ernesto Yattah, and I am also part of the team of Digital Health Information Network. Here Here in this slide, you will see that Unified Medical Records for Space Exploration Communications, which is initials UMRSX, is based on the ION DTN technology developed for space by NASA's JPL Jet Propulsion Laboratory. UMRSX is coupled actually with Unified Medical Records System, allowing to interconnect the healthcare system here on Earth, which includes hospitals, clinics, health insurance organizations, laboratories, radiology systems, and patients, and provide the benefits of the availability of health records for space travel. We have already developed the testing by doing a consultation of a patient in a simulated space facility to his doctor's office here on Earth, and the consequent diagnosis and prescription of the doctor being sent back to the simulated space facility with good results. And we plan to test this technology in a real space environment in the near future. Thank you so much.
Okay. Thank you. And also point out for people who think this is all just for government astronauts, there is an increasing effort to look at a human research program if there are a larger number of civilian tourists going into space. So this is not something limited just to government, but something that private sector in multiple countries may have a need for. Next speaker I have coming up. There we are, DTN Laboratory, Jorge Amodio.
Thank you, Dr. Perez, and thank you for the opportunity to share what we are doing here. My name is Jorge Amodio. That's how you pronounce it. I'm a pioneer member of Internet Society and, very long career, so I will not take too much time to describe myself. So I post a link, to my bio on the chat. I've been working on Internet of Things, or IoT, for a very long time. And when I learned about, the technologies that are associated with delay-tolerant networking, I got very interested on it. And I'm also very passionate about space exploration. I'm a product of the Apollo, generation. And I also, love to teach. Before the pandemic, I was teaching several camps, about space exploration and evolution of telecommunications. In 2021, I started thinking about how to put together a platform to do some experimentation and learn, and also use it to teach, about DTN, about delay-tolerant networking and the technologies. I put together some main features or goals for these. First thing, it had to be low cost and scalable. Low cost primarily because I'm funding it, but also, if schools or other institutions, particularly nonprofits, want to put together something like this, it has to be affordable. I'm not thinking about a server farm. These are very small and cheap boards, and it's very easy to implement. And also, with a big focus on, experimenting STEM education. So I'm combining multiple technologies. It has to be easy to program, including Scratch. On the camps, I've been working with middle school and, lower high school kids. So the idea was to create an interplanetary application. When I started to put this together, I shared it with Dr. Vincerf, and he instantly sent me to, you have to join PNC. So here I am. I started with Raspberry Pis, and small boards that you may see on those prototype, boards, to simulate, the telemetry from different type of nodes, both terrestrial nodes and, space nodes. And inspired on the Artemis mission, I started to put together, the idea of saying, okay, let's do something fun. Let's do something that is a simulation of all these objects, in Earth and space, exchanging information using DTN, using bundled protocols. And I say, okay, to make it fun, let's do it with Legos. So I started to, I grabbed all the Legos of my kids that are old now, so they didn't use it anymore. I got some used Legos and I started to put together the entire idea of this, implementation of the education, and R&D lab using Legos, and particularly with two segments, the terrestrial segment and the space segment, the moon segment, inspired on the Artemis mission. So what you see there, is, a segment that represents kind of mission control, different, resources there, that you can have, all the displays and lights that you see there are controlled. You can control them through the DTN network. And, it includes, many, different technologies, Ethernet, Wi-Fi, Bluetooth, LoRa, a swarm satellite, and now it's a company from SpaceX, and also cellular communications. Most of the nodes are running now GPS ION, and I'm starting to experiment with the micro D3 DTM. So this is a close-up, picture of how Mission Control Center looks like. And the other segment, is kind of a lunar base, is what we have in the moon. So there's some objects that are in the moon orbit, or are in the moon surface, like, the lunar research base, the, rovers over there. Then you have other things that are going to be in orbit, like, the gateway station. You're going to have some transition, from the station, orbital station, to the surface with Orion, and the lander. So in total, I have about 36 nodes right now that are local here, and about 15, are planned as soon as the supply chain, gets on. Oscar Garcia asked me, to share, what we are doing, for some, auditing of the network. This is not monitoring of the overall network that we have, as Alberto Montilla explained. This is local, but includes, information that we get from remote nodes. So I have one of the nodes that is particularly doing deep packet inspection with Wireshark. So we can see anomalies on the packets or on the protocols. I have two monitors here where I can see the logs of several key nodes, also monitoring the router to see that all the information is flowing correctly. And we are using this also with Scott Burley, that he's the, author of ION, to see where we can improve and detect and find and fix some glitches that we may have on the current, bundled protocol implementation. So thank you very much. There is the link, if you want to get more information.
That's terrific. And you got to love the Legos. That's great. Scott Johnson, SolarNet 1, on the IPN projects that you guys are doing.
Thank you, Dr. Pace. Hi, everyone. I'm Scott, and I'll be talking about the interplanetary networking related projects here at SolarNet 1. I began our IPN-related R&D effort by taking some existing hosts on the rack here at the solar-powered ISP, compiling ION on them, and configuring those hosts to become IPN-named nodes. After local testing and observation, I found one impediment to greater participation in protocol use was the difficulty of creating a working configuration file for ION. It was similar to deploying BGP in a router from scratch. And so as a result, I wrote and deployed a server application and downloadable client script to auto-generate working configurations at ph7ix.net. This allows a Linux host with ION installed to download a working configuration and begin using ION without the application-specific or protocol-specific learning curve associated. Also, during testing, I noticed that ION lacked IPv6 support. Well, why is this a problem? IPv4 addresses are becoming scarce and expensive commodities. With long wait lists at the RIRs and open market trading of resources, it can be costly to deploy IPv4 networks, particularly at cellular carrier scale. If we wish to test bundle protocol at increasing scale terrestrially, mobile phones make the most logical target. Over 80% of mobile phones receive only IPv6 service from the cellular carrier. IPv4 interoperability is maintained in these cellular networks via a method called DS-Lite, which is fine for client functions but breaks end-to-end connectivity, making using ION or any bundle protocol-based application a no-go on networks numbered this way. With appropriate IPv6 support, ION can be deployed to mobile networks as scaling of testing necessitates. To this end, we have been adding core library functions and dedicated convergence layer adapters, which support parsing of IPv6 address formats from the configuration files and IPv6 socket operations, respectively. Many network-related C library functions used in ION have been deprecated or otherwise incompatible for IPv6 use, and thus, large parts of the code base require minor and repetitive revision in migrating to appropriate replacement functions. A dedicated network segment was constructed for development and testing related to this project. The final project is a result of a series of collaborative discussions between Scott Burley, Dr. Cerf, and myself. The thought is that we could, in the future, build on the Moon, Mars, or Europa as examples, networks which function as the Earth's internet does, each with its own DNS root servers, routing tables, and instance of IPv4 and IPv6 numbering. We would want these networks to be able to talk to the Earth network and vice versa, and provide some level of normal, if delayed, service. In between, a network of bundle protocol IPN-based nodes would carry the traffic with protocol translator applications at the edge of each network, formatting for successful delivery across the next network segment. In practice, this approach would allow an email from an interested party on Earth to be sent to a recipient on Mars, and a scientist on Europa to retrieve a research paper recently published on Earth via the web, with neither of them having to learn new network-related skills to perform their non-network-related activities, and without address space collision. As we all know, any kind of space collision can be catastrophic, and that includes address space collision. Thank you all for your time.
Okay, that's terrific. And NomaTrack, DTN platform, I love this, for reindeer husbandry in the Arctic. Do we have Seno, or is Alberto going to be talking?
I think Jorge is going to be talking, Scott.
Okay, sorry, over to Jorge.
Yeah, it's going to be a very short presentation. This is, from Samographic and other partners from the Luleå University of Technology. What they're doing, they are using DTN to collect information, environmental information, to track reindeer herds, and also some environmental, information about, the North Arctic zone, including, monitoring the thickness of the ice underwater using ultrasonic buoys. And what they do, they also have drones that fly over those areas that have a DTN node on them, and each of the sensors have a DTN node that is collecting the environmental data. And when the drone reaches, the area, the information is transferred, the bundles of, the DTN protocol are transferred to the drone, and then the drone transferred to the base, and then they get sent, to a different node that I will talk about it later, to get processed and presented on a web application. That's it.
Thank you. That's very, very neat.
Yeah, so this one is the next application is from Wojciech Grasik, Samo's brother. He's in Slovenia. And this one is absolutely amazing. It's about a test bed, of DTN in the Postomia cave. I think that's the pronunciation. The cave is located, southwest of the capital city of Slovenia. It's about 20 kilometers long, and it has a track, for tourists, inside the cave, about 5 to 6 kilometers. And there's a little train, it's a 2-meter train. And then, what it does, it brings the tourists inside the cave so they can explore, they can walk by and, take pictures, whatever. But the issue is that they had to keep constantly monitoring, the environmental conditions of the cave. So what they did, they came up with a very clever idea of putting together a DTN node that is like a mule mounted on the train. It's that orange box that you see on the slide. It has a little, know that when you have the train going by, the stations that are collecting the environmental data, they are gathering that information from the sensors, collecting it, and when the train gets out of the cave, all that information gets transferred and represented on a website, like the diagram that you see, the sunflower diagram that you see on the bottom right. This is combined with what we were talking, briefly, in the previous presentation from Samo, that the information that we are getting, this one is from one of the lakes in Sweden. Samo is located in Sweden. So they are collecting all that information via ION DTN and including, the regular, internet to collect all that data, process the data, and present the data on a, reasonable graphical mode in a testbed portal that they have up and running. And this, has been running very recently since early, mid-June. So it's very new. They are keep evolving. There are some parts that are not 100% based on the ION implementation, and they are working on that project, and they are trying, to get some of the pieces together to make it work. Thank you.
Oh, that is awesome. Very clever. So I'd like to go back to Oscar as you talk about projects in progress.
Thank you, Scott. Well, finally, we are working as all the members, the big team of the pilot project working group. I will mention just some projects that there is a group working in ION DTN, that is DTN implementation from GPL, and LoRa DTN, that is implementation for short messaging that to connect between themselves. There is also a network discovery system developed by the Samo group in Europe in developing. As Scott mentioned, he is working in IPv6 with ION. I am personally working in projects for interfacing, DTN application for programming languages, the interface for developers to do this faster. And there's also 2 or 3 persons working in cross-compiling implementations for different operating systems. We are in a project to test DTN in satellite networks, and we're also meeting with companies that to help them including in integrating DTN to their developments. So these are projects in progress, and in the next presentation we are going to show their results. Scott.
Okay. Thank you. So first of all, terrific, a bunch of which I think hope gives our audience and people tuning in a sense of the range and diversity and some of the very clever applications that can be found to test out at relatively low cost the DTN networks. So as a policy guy, an international relations guy, not as a coder or technical guy, if I'm coming at this, the questions I have for the community, for you all and the people online is, what are the most important high-level technical unknowns that you're struggling with? Is it all just a engineering problem, or are there really serious technical unknowns that you're still struggling with? Is there a consensus across this community that these existing projects represent the most important problems that are working on today, or are these just sort of opportunistic things that have come up, but we don't really have clear priorities on them? And is there a consensus on maybe what the priority for future projects ought to be? You saw Oscar put a few of those out there. So there's this really good and interesting work going on. Are we working on the right problems, and are we working on them in the right priority order? And then secondly, for discussion, not really answers yet, the question is for sort of the governance and the policy types is going to be, if we had these technical solutions and were demonstrated, what would we expect government agencies and industry to actually do with that information? Would they expect government to put together an RFP? Would they buy a service somehow? Would this be a contribution to an international project? Would a company want to maybe make a commercial service out of some of this? What would we expect people to do with this information? And which of these projects would have the highest impact in terms of creating support for a planetary internet? So things like Legos to get students involved and excited and picture this, practical applications like the reindeer and the caves, again, show these sort of practical applications. But, what are the things that might have the highest leverage? I realize some of that is really a mystery, but I would be interested in people's thoughts. Again, for Q&A, we have some questions here, and I invite anybody, any of the panelists to respond to. If we make improvements to the ION code, for example, the SolarNet IP version 6 editions, can you contribute to the ION project via SourceForge and create a branch and then submit a merge request? And I believe there is an answer saying that, that there are multiple different transport layer possible for the bundle protocol. And I believe Alberto was saying something about releasing code. Does somebody want to get online on that one?
Sure. So we'll in the past, we haven't been very consistent into how to submit those. I know that the first person within the group that tried that process was Scott Bordley himself with the interregional routing. So I think this is a great point, Lee, for all of us to make sure that we are consistent. I think we have used different avenues, like, as I said, during the chat, we, for example, in the case of management, we went directly to Ed Birain and his team on APL to make the change. But thanks for the hint, because I think that's a good point for all of us to be more consistent into, submitting those changes so that they can be considered faster.
Very good. And I don't know if anybody wants to comment on this one. We had a comment, I think, from Vint about, flow and congestion control and interregional routing as tough challenges. Are any of the projects getting near those kinds of questions?
Scott, I may make some comments on that, because in terms of connectivity and the network discovery project that is working, Samo and also Scott has been testing, is related to the part of routing that is very different in space that it could be in Earth, because the distances are an issue. And also another of the topics that we have been working is like what we would say, like a DNS model. Alberto and Spatium have been working on that, and myself as well. A congestion is other issue that we are going to work on the network. And one of the reasons of the existence of the network is to test these kind of problems in a controlled environment as Earth would be. Thank you.
Very good. Jorge?
Yeah, just a quick comment. This is something that we always discuss on our meetings, about when you talk about the questions for the technical community. From the technical point of view, one of the important things that we need to keep working on, and we learned this, from our experience, putting together and, developing the internet, is the standards. And, we can do many things and we can have many islands. But if we don't find a way to develop and implement standards, it's going to be very difficult to scale and manage, any network. So this is a lesson, that we learned from the internet, and Dr. himself is always very helpful, trying to put us on the right track about that.
Very good. Well, I see sort of a comment about the importance of demonstrating reliable and scalable operation of BP version 7 and interoperation of these various implementations. So, but that requires providers of the space vehicles and these services to be aware of BP version 7, LTP, and implementations. So is there a way to get word about that out? Is that well known among spacecraft and satellite builders, or is this still a kind of a boutique function, within a specialized community?
In that topic, we are trying and establishing contacts with satellite providers and the space community as well. We are a group of volunteers, and we appreciate every help that in that terms, because as you say, this technology needs to be tested in a full operational environment, for sure.
Okay.
Yeah, there is a piece of very recent news, released by Internet Society, that SpaceX just joined Internet Society as an organizational member.
That's terrific. And there are standards in other areas. I mean, I'm familiar with what's going on in the CCDS, Consultative Committee on Space Data Standards, and passing information back and forth for space situational awareness. So this is certainly a place to. There are places to go, but that doesn't always mean that the builders and operators are always aware of what can be done. So this is maybe more of a partnership with NASA and other space agencies who are potential customers as to maybe what the benefits might be of incorporating this and building for the future, building for long-term architecture. Let me ask you another hypothetical. If you had, suppose there was, say, $1 million just here plopped to doing projects, so you could buy really great Lego sets. How would you allocate? How would you prioritize? Say $1 million for a bunch of peer-reviewed projects, highest priority items. If you had resources like that, what would be the most important thing to do to advance demonstration and acceptance and hopefully adoption of these kind of protocols for interplanetary communication? What problem would you want to solve first?
I think that with some resources, something that we really excited to do is to test a real space application. Today with microsatellites, CubeSats, it's not that difficult. If you find somebody that can give you for free lunch, to get a satellite in orbit, that would be a real, test of an interplanetary or, space application. Go ahead, Oscar.
Okay. So
yes, I would like to mention, Scott, that if that's an offer, we are very keen to talk about that, about our priority, for sure.
I'm just thinking about an ask to Elon Musk in case the Twitter deal falls through, that he'll have some cash.
I don't know if it's gonna have anything left over.
May not be. Okay. Hey, I see we're up at the top of the hour, and that we've hit our mark in terms of providing material on time. I thank everyone for the discipline and getting through this. And I hope our audience kind of appreciates the range and diversity and excitement of things that are here that are going to are the foundation for next generation of certainly lunar and Martian communication and maybe more. Anybody have any last minute comments they'd like to make?
I would just like to say thank you to the audience, to Laura that has helped us very much in the development and of this webinar, to Kaneko, Vinton and all the board of the IPNSIG, and especially to you, Scott, for being so kind and helping us and very, very professionally and very good to do this webinar for all the community. Thank you very much. And thank you to all.
Our pleasure. And look at the IPNSIG Academy and send any questions there. With that, let everyone have a good evening or a good day, wherever in the world you are. And here's our upcoming programs, and we hope to see you again. With that, we're out.